Hello and welcome to lesson 2 of 3 in our short, simple transport 3B respiratory system unit. So we're already on to homeostasis. You know that our last topic of every unit is homeostasis. Last class you learned about the mechanics of breathing, and if you've completed 8-1, you basically know the structures and functions of the whole respiratory system. So how do we control respiration? So homeostasis, you should know what homeostasis is by now, maintaining that constant internal environment. It's a question on every test and every unit we've had so far. So basically it's your change in breathing rate. So we talked about our breathing mechanisms last lesson, how you breathe in, breathe out, Boyle's law. But obviously we know that our breathing rates change. We also talked about you breathe without having to think about it. Thank goodness. If we had to think about breathing, we'd all be dead probably within an hour. Like, oh, I forgot to breathe. So your body naturally takes care of that. Now, what are some things that change your breathing rate? I think it's pretty obvious. Some things that you've noticed that speed it up. We would have done an activity where we would have tested our respiration rate, but like I said, it's a little bit high risk level right now. So we're going to talk about the medulla oblongata. That is a part of the brain. I know we haven't studied the brain yet. That will be covered in our last unit, the nervous system. But the medulla is the bottom part, basically the base part, the stem of your brain. So that's where it is. Now, when that gets activated, it increases your respiration rate. So we're unaware of this. And when we talk about the nervous system, the medulla oblongata, that takes care of things that happen automatically that we don't have to think about. So this gets activated. We'll talk about it, what activates it on the next slide. But when this gets activated, it increases your respiration rate. So what activates it? Well, we've got things called chemoreceptors, and we have two of them. We have chemoreceptors for carbon dioxide and oxygen. Now, a misconception is most people think that when, like, if you think about doing any kind of exercise, I think if you've run or you maybe do the 1600 meter, it's like, oh, you're huffing and puffing. A misconception is people think, oh, I need more oxygen. I don't have enough oxygen. That's why I breathe heavy when I exercise. It's actually the opposite. There's more than enough oxygen in our environment. If you took Chemistry 30S, remember the most abundant gas in our atmosphere is nitrogen. Oxygen is second, but there's more than enough oxygen that we need in the environment. So how can we gasp for air after we exercise? It's not a lack of oxygen, it's actually the buildup of carbon dioxide. When you're exercising and running and doing the 1600, you get that buildup of carbon dioxide. So you're actually breathing more to get rid and expel of that carbon dioxide faster than when you're exercising. So it's the high levels of carbon dioxide when you exercise that activates your medulla. So that's a very big misconception. It's not like, oh, I'm gasping for air. Well, no, you're not. There's more than enough air, more than enough oxygen around you. It's just when you're running or exercising heavily, you're getting that high buildup of carbon dioxide, more than your body can handle. So you increase your breathing rate to breathe more, so you're expelling the carbon dioxide more. And then, so again, it's that, remember we talked about that negative feedback system in unit 1. So you're exercising, you've got high levels of carbon dioxide. How do you get rid of it? The medulla gets activated and says, okay, I'm going to breathe more. So when you breathe more, you're expelling more carbon dioxide. Then when your levels get back to normal, you don't need to continually be at a high rate. So when you're back to normal, those chemoreceptors get shut off, then your breathing rate returns to normal. And it's very sensitive. A 0.3% change in carbon dioxide, that's all you need to double your breathing rate. So next time you're running the 1600 meter, you should be saying, oh, thank you, medulla oblongata, for regulating my respiration rate so I can continue on my 1600 meter and score my time that I've been working towards. So that's the chemoreceptor for carbon dioxide. We do have chemoreceptors for oxygen. They are less sensitive, and like I said, because the atmosphere around us has more than enough oxygen that we need. So the problem isn't usually that we don't have enough oxygen, it's that buildup of carbon dioxide. So when do we activate our chemoreceptors for oxygen? Well, again, those of you that took Chemistry 30S, this is our Unit 2 gas in the atmosphere unit. At higher altitudes, the air is thinner. And by thinner, we mean it has fewer molecules. So if you go up to high altitudes, that's when there's not enough oxygen, and that's where your chemoreceptors for oxygen would kick in. So where we are at sea level, usually it's fine. But when you go very high, that's when you get a drop in oxygen. So look, again, it's cut off, but in your notes. At sea level, 100% oxygen levels. If you go all the way up to high, 32% only oxygen levels. So that's when your chemoreceptors for oxygen would kick in. I was in South America, well, probably about 10 years ago. I spent a couple months traveling around South America, and I've heard about something called altitude sickness, which I always believed in it, but I always thought, oh, really, is that real? And it was. I was in Cusco, Peru, and if you don't know where that is, that was a stop before I went to Machu Picchu in Peru. So I spent some time in Cusco, and I was there, and it's a very high altitude, and you don't notice that there's a lack of oxygen. You're like, oh, you go about your daily business, you're fine, and then all of a sudden it just hits you. You have no energy, you can't do anything. It's like, whew, what happened? Well, that's your body adjusting to these different oxygen levels. So after a day or two, your body, again, homeostasis, adapts to the environment around you. But that was the first time I've ever had altitude sickness, and it was weird. It just comes on suddenly. It's like, huh, okay, yeah. So my body was having to adjust to the lower levels of oxygen at that high level. Okay. And then carbon monoxide. I'm sure you've heard about carbon monoxide. The problem with that is it competes with oxygen for binding to hemoglobin. If you did your homework in the circulatory system, remember the red blood cells contain hemoglobin. It's the hemoglobin in the red blood cells that actually pick up the oxygen and bring them to your cells for cellular respiration. See how the two units are connected? But the problem is it competes with oxygen for that same binding spot, and unfortunately it beats out oxygen. So when carbon dioxide is present, it's 20 times more likely than oxygen to attach to your hemoglobin. And that's what's getting into your cells instead of oxygen. And that's bad because the more carbon dioxide the hemoglobin picks up, the less oxygen it does. And the whole function of hemoglobin is to attach oxygen to it so it can bring it directly to your cells. 0.1% carbon monoxide in the air is lethal. And we've talked about gases, they are odorless, they are colorless. So if you've got a carbon monoxide buildup in your home, I don't want to scare you, but that's dangerous. So not to be morbid, but I'm sure you've heard of, you should have carbon monoxide detectors in your house and make sure they're functioning. We've all heard those sad stories where a family sometimes dies in their sleep overnight because there was a carbon monoxide leak and their detectors weren't working. So I know it's a little morbid, but so it's not really a chemoreceptor, but that's a problem if carbon monoxide is present in the environment. So maintain your homes, maintain your carbon monoxide alarms. Okay, and I have another video. Again, like I said, we have 2 labs. We do unfortunately have to omit the respiration labs this year due to COVID. But what I've done instead is I've made a COVID-19 worksheet. I made it last year, but it still applies because obviously we are well aware of COVID-19 and that has affected everything in our lives, to who we can see, what we can do, how we do schooling, all affected by this virus. And the main system that COVID-19 affects, well, COVID-19 is the disease. You're going to learn about the virus, the proper name of it, how it attacks your respiratory system, why people might end up on ventilators if they get COVID-19. So we're doing that instead. And I think it's more timely, and we should be aware of, well, it's a respiratory disorder that's basically shut down the entire world, well, for a year plus. So your homework today is just to do the review sheet plus to start working on the COVID-19 worksheet. And oh, look at the funny joke, you take my breath away, haha, that's not funny. So that's why we know we don't smoke, we don't vape. If we want to have healthy hearts and healthy respiratory system, why would we clog it up with things from cigarettes and from vaping? The other joke I have, the lungs. Oh, we got you something. Oh, I love it. I'm going to share it with everyone. Oh, okay. The lungs and the heart sharing oxygen. So there you go. The 2 systems are interconnected. Okay, so today you're going to start the COVID-19 worksheet. On Friday, there's no class call, but I am going to leave notes for you. And then you have Fridays, after you've gone through the PowerPoint and the video on Friday, you have the rest of the time to complete the COVID-19 worksheet. Okay, have fun.